Hey everyone, Morgan here coming back at you to talk about solution concentration for AP Chem. We are on page 4 of the Properties of Solution outline. Now, molarity. You already know molarity. Capital M equals N over V. Or, let's get a little more specific now. We're going to say moles of solute divided by liters of solution. It is the total volume that we are referring to. A new unit for us today, molality, which we express as a lowercase m, which is the moles of solute over the kilograms of solvent, just solvent, not the total solution. We typically say N over kg for that one. Mass percent is the mass of A divided by mass of B plus mass of A, or mass A, mass B, doesn't matter, you can say it either way, times 100%. And mole fraction we have worked with before, Greek letter chi, the mole fraction of A would equal the moles of A over the moles of A plus the moles of B. Okay. Now, let's dive in. Let's do some math. Okay. We have 5.84 grams of H2CO. It's in 100 grams of water. The final volume is 104.0 milliliters. So, I need no moles. 5.84 grams H2CO times, 2 plus we got 14. 14 16 is 30, 0.01, 0.01, and a 0.01. So 30.03 grams per mole. And when I ran that through my calculator, I got 0.195 moles. So the molarity equals moles over volume, which equals 0.195 moles H2CO over, now the volume, 104 milliliters divided by 1,000, get 0.1040 liters, and that's about 1.87 molar H2CO. Okay. The molality, M, is 0.195 moles. Now, I'm going to divide by 0.100 kilograms. Now, what have we got going here? It's just the solvent, okay, not the total solution. So that was the 100 grams of water. And that is 1.95 molal. Mass percent, okay, not so bad. I have 5.84 grams divided by 5.84 grams plus 100.0 grams. Multiply this by 100%, and that comes out to be 5.52%. Okay. Now for the mole fraction, I'm going to need the moles of water. So 100.0 grams times 1 mole is 18.02 grams. And I actually know this. This is 5.55 moles. Okay. So the mole fraction is going to equal the 0.195 moles over 0.195 plus 5.55 moles. Moles cancels, and this is 0.0339, and it has no unit. It is considered to be dimensionless. Okay, moles over moles cancels out. All right, so top half of the page there. Bottom half of the page there. Okay. Hopefully that's good for you. Now, let's go on. Do a question about percent composition. Hydrogen peroxide that we can get at a beauty shop is 6%. 6% means that 6 grams out of 100 grams are the H2O2. Now, in this question, I have 500 milliliters. So assuming it's 1 gram per milliliter, it's a pretty safe assumption. For 500 grams, that must mean 30 grams are H2O2. And I'm just going to say 30.0 for clarity here. 30.0 grams H2O2 times 1 mole would be 34.02 grams, which equals 0.88 moles. I'm just doing that to get it out of the way. This was really what the question was asking. Now, if I have 500 milliliters or 500 grams, and 30 grams are H2O2, 470 grams are H2O times 1 mole, 18.02 grams. Now, let me just run that through here. 470 divided by 18.02, and that's 26.6. Okay, give or take. Yeah, 26.63. It's going to be 6. 26.6 moles water. Okay. So to find the mole fraction, 0.88 moles. This is the mole fraction of the peroxide. I could do the mole fraction of the water also. Over 0.88 plus 26.6. Okay. Moles cancels. So 0.88 divided by parentheses 0.88 plus the 26.6. Close that off, and I get 0.0320. 0.0320 is my mole fraction. Okay, we could have little rounding differences. I used 18.02. Some people might only use 18. All right, molarity. Moles over liters. Okay, now what's that going to equal? I'm going to have my 0.88 moles over total volume of 0.500 liters. That's 1.76 molar. I could put H2O2. And my molality, 0.88 moles. And here's a really important thing. 0.470 kilograms. It was 470 grams. So I divided that by 1,000. Because remember, that's solvent only. And that's 1.87 molal H2O2. Okay. Get that centered there for you. Okay. Now, liquor, when sold, is typically defined by the proof. Okay? Now, proof is a 0.5%. So if a liquor is 80 proof, that means it's 40.0%, meaning that there are 40.0 grams of C2H5OH out of every 100. Let's just assume we have 100 milliliters and that the density is 1, so it's 100 grams. I'm going to convert that, 1 mole. And the molar mass is 46.08. That equals 0.868 moles. Okay, that's the C2H5OH. Now just so I have it handy, that would mean 60.0 grams are water, 1 mole, 18.02 grams, and that equals 3.31 moles of water. Okay, so the molality of this solution, lowercase m, equals moles per kilogram, which equals 0.868 moles, divided by, now that's 60 grams of water, divided by 1,000 is 0.0600 kilograms, which is going to equal 14.5 molal C2H5OH. Now, the molarity, capital M, N over V, is 0.868 moles, divided by, it's 100 milliliters, so that's 0.100 liters, and that equals 8.68 molar C2H5OH. And the mole fraction would equal, I could do it, C2H5OH. I could use a little subscript there. 0.868 moles over 0.868 plus the 3.31 moles. Moles cancels, and that's 0.208 without a unit. That is dimensionless. Okay, so I'm going to put this up to the top for a moment. Pause if you have to. I'll count to 5. 1, 2, 3, 4, 5. Okay, bottom. Pause if you have to. 1, 2, 3, 4, 5. Okay, there you go, folks. Some concentration questions, and I would anticipate there'll be plenty of those on your next test. All right, thanks for tuning in. This is Morgan signing off.